All right, guys. So I'm going to take a break from our regularly scheduled programming to talk about what is on everyone's mind, which is coronavirus, um, the thing that has caused you guys to stay home from school for the last 2 weeks or last week. I wanted to talk about this because there's a lot of science behind it. There's a lot going on right now in the world of science to combat this. So before we dive in a little bit to Corona, by the way, this has nothing to do. This is not going to be on your final. Maybe I'll ask a question or two, but this is not. This does not have to do with a lot of things. But I will tell you, for my AP Environmental Science class, they like to pull from current events. So you could very well see something about Corona on the test. For everybody else, this is just more for fun. Everybody's going to get this. I'm going to get this lecture. Hopefully, not get this illness, but get this lecture. And I think it's just good to kind of have a little bit of a scientific understanding of what's going on. So let's go ahead and pray real quick, and then we'll get into it. Lord God, I thank you, Lord, so much for this group that is watching this. I pray, Lord, that you give them peace that only you can give, Lord, that peace that transcends all understanding, that you give them hope. That we're going to hopefully come back to school at some point soon, and our lives are going to kind of go back to normal. For those that might be sick, Lord, with this, I ask that you give them comfort and relief. Lord, be with them and their families as they deal with this virus. In Jesus' name I pray. Amen. All right. So, for a little disclaimer here, I'm not a doctor by any means. I am not a pathologist. I do not work for the CDC or work in pandemics or epidemics or anything of that nature. So take what I am saying with a grain of salt. This is just my interpretation from somewhat of a scientific mindset into the current events of today and kind of what we're doing to combat this issue. So again, take that for what it is. I'll do the best that I can to be as accurate as possible, but still reach out into the vast amount of information out there and draw your own conclusions. Is probably the best advice I can give you. So first off, let's talk a little bit about viruses. We don't talk a lot about viruses in this class simply because in bio we're teaching about life. Viruses, while they are kind of alive, they're also not alive. Because one of the reasons or one of the necessary components of life is the ability to reproduce. Viruses cannot reproduce on their own. They reproduce with literally the micro hijacking, if you will, of certain elements of a living cell. So what they do is they infect themselves into that cell, and then they hijack all the equipment that the cell has, both their DNA/RNA. Coronavirus primarily uses its own RNA. It takes the RNA and DNA polymerase and causes it to replicate rather than your DNA. It replicates its own DNA, and from that it then uses ribosomes within the cell it hijacks the functionality of the ribosomes, and instead of it producing proteins for you, it starts to produce proteins to manufacture the virus. Literally, your cells become a little tiny manufacturer of that virus, and that's why viruses are hard to kill. They're really small. They don't have the same vulnerabilities that living things have because they don't have all the components. With a living cell, you can kill it by simply taking away part of that ability to live, right? To reproduce, to be sheltered from the world. Viruses don't have all those components. They're really simply designed microorganisms that are, again, incredibly tiny and very hard to kill. So they basically come into the cell and they take it over. Now, one of the things that we don't talk about a lot, because when we talk about viruses, we're talking about ourselves. I'm going to go through this pretty quickly, by the way, so I don't want to keep you guys for real long. But other animals get viruses. So birds in particular can get the flu. You guys hopefully remember a few years back we had the bird flu. If you guys remember your history, it seems like for the last 10 years we've had something that was really dangerous and scary kind of come about that we thought everybody was going to get. And this year is no different. I will say that the actual threat this year is a little bit more extreme. It's a little bit, and that's why you see the very drastic response that we were having, where literally states have shut down. Illinois being one of them. So um, the response is due to the fact that this particular virus is a little bit more of a threat. And we're going to talk more about that here in a second. But birds can get the flu. They get influenza. We call that the bird flu. It's got a particular name. I believe it's H1N1 was the last one. I think that's the bird flu. But we've also had flu that we were concerned with from swine, from pig. So that was the quote-unquote swine flu, or if you wanted to, you could call it the pig flu. So they get viruses, and usually it doesn't do much to us. It's bad for the pigs or the birds, but it's not that big a deal for us. But sometimes the flu can get mutated because viruses replicate really, really quickly. They are prone to mutation. A lot of times that mutation does nothing, but sometimes, very rarely, that mutation will allow that virus to go from the bird or the pig or whatever animal you want and allow it to pass to another species. When that happens, we call it zoonosis. Okay, so this passing of one virus to the next, again, is known as zoonosis. That's what's happening here with this particular flu. So what happened with coronavirus, which is what the media kind of calls it, we're going to get to those names here in a second. It happens relatively often. Oh, I cut off the last line there. What that's supposed to say is it's often not super contagious. So while you can get this zoonosis, you can get the passing of one virus from, let's say, a bat to a human. Oftentimes, it doesn't result in a very contagious very contagious strand of that flu. In fact, this happens pretty often in the environments that we have domesticated animals. If you've ever been to a poultry farm, you know that there are thousands of chickens, thousands of birds in one really small space. They're packed in. So obviously, and then there's people around harvesting those birds. So obviously, it's possible for that H5N1, there it is, there's the avian flu or the bird flu. It's possible for that bird flu to transfer to another person, and it does occur relatively regularly. But it doesn't result in a super contagious form of that flu. Oftentimes, that person might get a little sick, but he or she doesn't pass that on to anyone else. COVID-19 is a little bit different in that its zoonosis originated in bats. Okay, and oftentimes when you guys hear about these, a lot of times the virus originates in a bat. So why does the bat work really well is what's called a reservoir host, This means that they carry viruses. So why are they like really prone? Again, if you go back and you look at all these different viruses like H5N1 and the swine flu, why is it that oftentimes bats are involved with that? It's for a lot of reasons, but I've listed them down here. One, bats live in huge colonies. There is no social distancing with a bat. Okay, when there are 60,000 bats in one cave, they are right next to each other. They can literally feel each other. They're touching one another. So there's a lot of transmission of whatever virus they have from one bat to the next. They also live a really long time, which is surprising because most small mammals, the rate or the age that you live to is often related to your heart rate. Small animals have a really high heart rate, which means they don't live very long. Okay, a field mouse might live 1 to 2 years. Okay, a bat, which is relatively the same size, same kind of biomass, can live 20 years. Okay, so they are in these large colonies for large periods of time. They are very diverse. So one of the reasons that we also see a lot of bat zoonosis, where bats are kind of starting this process, because bats are just more represented in the mammal kingdom, or in the animal kingdom rather, and specifically in the type of animal that we are, the mammals. So bats are mammals as well. They're furry covered lactating organisms just like we are. They make up, though, a disproportionate amount of all the mammal species on Earth. In fact, 1 in 4 of all species on Earth are bats that are mammals also. Okay, not 1 in 4 species of all the species, but 1 in 4 of the mammal species on Earth are bats. So because of that, they are overrepresented in that particular sector. They also then are probably going to be overrepresented when it comes to viruses attacking mammals. It just kind of makes sense. But the last one, and this is probably the most damning one, if you will, it's the fact that they have a really high metabolism, which has suppressed their own immune system. So bats are the only mammal that can fly. Now, what does that have anything to do with zoonosis? Well, if you can fly, you are creating a lot more energy through metabolic processes than almost any other organism, because flying takes a ton of energy. Because of that, because of that high demand of energy on their system, that high metabolism that bats have, their immune system has adapted to tolerate more foreign genetic material, basically more mutation than most other organisms. Because they are constantly demanding such a high amount of metabolism from their body, it's straining on their body, which causes more free radicals, which causes more genetic mutation and more foreign genetic material within their bodies. So their immune system has adapted to kind of allow for that to happen. That means that if a virus comes into them, their immune system doesn't attack it as regularly as maybe another organism. A lot of this is speculation, okay? And like I said, I told you the disclaimer before, I'm not a doctor. I'm just giving you what I have researched and the information that I have gathered. But these are the reasons that bats always seem to be kind of at the forefront of this. But understand that bats are not the only player that has caused this particular case of zoonosis. And this particular transmission of the virus from animals to humans. There's another host that is a part of what we believe this is what we believe has spread this virus around the world, and that's what's known as an amplifier host. So again, if bats are considered the originators, they are not what actually caused the spread from one person to the next. So bats might have mutated the virus initially, but then we had to get an amplifier host that actually started to spread that virus from one human to the next in China. This particular animal, an amplifier host, is an animal that carries that mutated form of the virus and causes it to mutate even slightly more to be more contagious to humans. In this example, when it comes to the coronavirus, we believe that it was a pangolin. If you don't know what a pangolin is, it's basically an anteater that looks like an armored truck. You guys can see it down there in the picture. It's really cool. It's a neat animal, and it's something that you would probably find in some wildlife markets in Asia. So there's some speculation that believe that this particular organism is what actually caused the transmission from that virus to this amplifier host to an actual person, or from this amplifier host to an actual person. So now that we kind of know how it originated, let's kind of identify these terms, because I'm sure you guys have heard coronavirus. I'm sure you've heard COVID-19, which is sort of the term that now the media has adopted. They're no longer saying coronavirus as much. And then, of course, well, not of course, the one that's probably the least familiar is SARS-CoV-2. So I want to kind of highlight what these are. First off, coronavirus is a all-encompassing term that actually is a subset of viruses that used to have 6 different types of viruses in it. As of December 31st, or December 30th, I can't remember, when they classified this particular strand of coronavirus, also known as SARS-CoV-2, it became 7 different viruses that are now considered coronaviruses. They're called that because the spikes that are all over this virus, all over the capsule of this virus, look like a crown. They give it a corona sort of appearance. Corona means crown, so that's what we call it. COVID-19 is actually the disease, in the same way that AIDS is the disease of HIV, which is the virus. COVID-19 is the respiratory disease that comes from coronavirus. It's the name of the disease the virus causes. It stands for Coronavirus Disease 2019. Again, the reason we call it 2019 is because that's when we first isolated this particular strain of the coronavirus, also known as SARS-CoV-2. The actual name, as I've mentioned a couple times now, is SARS-CoV-2. It's a strain, of the SARS virus that you may have heard of in the past. Which, man, I'm trying to think of what the SARS stands for right now. I know it's acute respiratory syndrome, severe, I think, acute respiratory syndrome. That's what SARS, I believe, stands for. Go ahead and look that up for me. But again, because it's another strand of that, we call it SARS-CoV-2. All right, so this is why you're at home, guys. I wanted you guys to understand why we're taking these precautions. There's some people that might say that these are extreme precautions and maybe a little bit too far. There's some people that might say that this isn't enough, that we should be doing more, that we shouldn't be coming back to school next week, or well, I think it's like April 7th now, whatever it is, beginning of April, that we should be coming back, or that we're supposed to come back to school. Some people are saying that we shouldn't do that. Listen, I'm not here to tell you which one's right. I'm really not. I just want to give you some information, and I want you guys, as young scientists, if you will, to take this information and think about it and decide for yourself what you think the best course of action would be. Decide for yourself how to properly interpret this information, and you can decide if you think that we are being over precautious, or if you think we're not doing enough. You guys are young adults that are going to start to think for yourself anyway. I don't want someone to have to tell you, okay, how to think. Now, that said, when it comes to things that you don't understand, obviously submit to the hopefully the more learned knowledge of people that are doctors and professors and things like that. But take the information for what it is, information from someone else. Try and understand it and try to interpret your own conclusions, because that's really what life is all about. So these are some of the things that are true about COVID-19. Again, the disease that is caused by this particular strain of the coronavirus. It has, as of right now, I think this has been lowered since I wrote this, but it has about 4% mortality rate, which means that of all the people in the world, and I want to say it's almost 3% now, so it's went down, but of all the people in the world, 4% who get this illness are going to perish because of it. They're going to die because of it. Very sad, definitely not a good thing. 4% is not relatively high. SARS, for example, the actual, the first virus that this mutated from, potentially, they're in the same family of viruses. It has a much higher mortality rate. That's not why you're at home, okay? You're not at home because it has a 4% mortality rate. In fact, the mortality rate for people your age is almost zero. It's very small, okay? So that's not why you guys are sitting at home right now listening to this via your cell phone or your computer rather than hearing me talk about it. It's because of this R number. Okay, the second thing on this list. The R number is the number of people that the infected person can potentially infect. Okay, so think about that. If you got sick with the coronavirus, God forbid that happens, but if you did, this would be the number of people that you could potentially expose to this and infect because of your infection. Okay, so anything below 1 is considered manageable when it comes to the R value. R value is like golf. You want the lowest number possible. Okay, I know most of you guys are like, I don't play golf, but you want a low value. Okay, higher is bad. So an R value of less than 1 is considered a manageable virus. Everything's okay. Everything's kind of under control. So Corona's R number right now is between 2 or 3. And that doesn't seem like it's probably that much higher than 1, but this is very contagious. That means that 2 or 3 people will be infected from every 1 person. That's called exponential growth. Okay, and it's that has everybody kind of worried about this circumstance. That and the fact that, 1, we have no treatments for this particular virus because it's brand new. We just isolated it a month ago. Okay, 2 months ago, I should say. We have no treatments right now. That includes no vaccine. It'll probably take almost a year before we get a vaccine for this particular virus, but they are trying to fast track that. It is very contagious, again, and that kind of relates back to the high R value. And it's airborne. Okay, a lot of times viruses, once they become airborne, it's just so much easier to spread. Because if I touch something that I'm infected with coronavirus, you have to come and touch that same surface. So, I mean, you could take reasonable precaution and just not touch things and make sure that you wash your hands and everything's okay. But when it's airborne, you can't avoid air. Okay, that's the big issue. Even if you are far away from somebody, if you're in a place like Walmart, okay, air diffuses, and pathogens within the air diffuse. So that means they spread out from an area of concentration to areas of low concentration. So that you can be, I mean, it's going to be much more likely if you're close to somebody, but you can be 5-6 feet away from something, and if you're 5-6 feet away from a surface, obviously you're not going to touch it, you're not going to get that virus. But if you're breathing the same air that someone coughed in, that might have that virus, there's a likelihood that you're going to catch this particular disease. And again, at your age, it's not that big a deal. It's scary when you think about like my parents' age. Okay, going to my parents' house. I can't do it right now because I can't risk necessarily, because that 4% is much more in line with their age group than it is mine. I can't risk losing them, okay, and infecting them if I was right now carrying that virus. Okay, so I don't want to leave you with first off, I'm going to talk about hope here in a second. But listen, this too will pass. There are things right now that we're working towards. In fact, there was a recent press release within the last couple days here, last week. Chloroquine and hydroxychloroquine, which are old malaria medications, have been shown to drastically reduce this virus. Okay, the potential of this virus. That then paired with usually a common antibiotic like a Z-Pak, it's had 100% results. So I mean, like, it is literally killing the virus. So this is a big push right now. Doctors can prescribe this at this point. We are getting more and more medication from. Actually, it's even being donated from other countries. So because we're one of the bigger impacted places. So I mean, this is definitely a reason to celebrate, reason to be excited. Hopefully that will solve a lot of this. Also, we are self-isolating right now in a lot of places. We are staying away from congregations, lots of people. That's a way of kind of self-vaccinating, even when there's not a vaccine. So these are good things. These are good precautions. I know it can be scary, guys, but I want you to understand that everything will be okay. I gave you guys a couple verses here. John chapter 10, verse 10. It says, "The thief comes only to steal and kill and destroy. I have come that they may have life and have it to the full." Sometimes this is translated as have it in abundance. Guys, I just want you to understand that God does not promise us a life without trouble. He doesn't say that. There's no Christian. If a Christian tells you that they're going to not have trouble in life, they're wrong. Okay? What God promises is that we will have life to the fullest, which means that we will have times of trouble and we will have times of great joy. We'll have both. We'll experience all of it. But I want to leave you with John chapter 16, verse 33, which I have quoted so many times in my life. It says, "I have told you these things so that in me you may have peace. In this world," listen to this, "in this world you will have trouble, but take heart. I have overcome the world." Guys, everything will be okay. I promise.